So we're going to go on with the last presentation. As I said, like this presentation is relatively short, and there's no coding exercise anymore after that. So after this, you can continue working on making the last thing work, or with any of the bonus questions. Ask me anything, or we'll have a short Q&A at the end of this as well for the whole presentation, all 7 presentations, in case something you didn't understand or anything like this. Feel free to also interrupt me during this one as well. So we'll go through how to build DSLs. One of the things that a lot of people are excited when they mention Kotlin, there's probably like 3 things that people will tell you. There's nullability, there's data classes, and there's DSLs. So we're going to look at how to make DSLs, because we learned about the other 2 already. But before that, like, why are people so excited about DSLs, and why, what are usual use cases? So most DSLs actually revolve around doing something that is relatively complex, that you have to do a lot of boilerplate code to actually make it a bit shorter. And a lot of these things that in Kotlin are expressed as DSLs, they have a very, they're very often implemented as builders inside inside Java. And the thing about builders is that you have these methods with chains and things, and the problem is really when you end up on something like this, where you have an object which is kind of complex. It's really hard to actually have a single expression that can generate this class. So you probably have to, in this case, most likely what you'll do is you'll break your build over here, you'll create a buffer, you'll have like 10 lines of other code, and then you'll continue down here with something like mock_response.widthBody with the buffer that you create, and then build it and things. And then your code gets very messed up. Like this is relatively clean code. It's considered clean code in Java, and it's relatively readable, and it's fine. But once you start encountering things like this, and if you have like 3 of these objects which are complex to do, you either create them somewhere up here, and it's not very immediately obvious that they kind of belong to this logic, or you break your builder here, you create them, and then they're kind of like you continue your builder pattern somewhere down here, and your code starts looking all over the place, and then you wonder like what to call this. You give them some nonsense names like this is body, or this is buffer, or and it doesn't really reflect like what's the real use for this thing. Like this was probably some JSON object or something like this, and but rarely it gets named correctly. It usually gets named after where it's used or what it is. And basically DSLs try to solve this problem and make it much more readable. So what you usually do in Java to implement this thing is, this is another thing that kind of just adds noise to all of your code. You basically have some builder, and then from each of these methods you return the same builder. So these methods in the implementations, you usually have to like do whatever you want to do, and then return this, and then return this again and again. So you have like this boilerplate that is everywhere. They just like we've gotten used to these in Java, and we consider this clean code, but it can be better, and that's where DSLs come into play. Something that you'd rather probably write is something more like this, right? So you want to create your mock response, you give it some code, you give it a header, and this is how you create a body for it. This is a relatively complex operation. It's actually an extension function that kind of gets this JSON object, parses it, blah, 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 and then returns it into the body. But this isn't here. So even if this wasn't a single function, this is like just for brevity so that I can fit it on the slide. But like even if this was a 5-line, it will still be inside your builders. You still have, you can write as many expressions as you want in here, and it still doesn't get distracting, and your code doesn't get messy. It's not all over the place. You know, in this Lambda, I'm trying to create a body right now, and by the end of it, I'm done with that. So even if these expressions get very long and involved, it's still relatively clean code at the end. So in this one, in this presentation, I'll basically walk over the steps of how to transform this thing down here into something that compiles to this. So the first thing we do is we declare this mock function that is outside. This is a top-level function. It lives outside any class. And the thing here is that it accepts a receiver function on its own and returns already the response that we want. And the body is relatively straightforward. It just basically uses the apply keyword to invert for a bit of inversion of control, so that it will invoke basically this init method with this init function passing in the builder that it created, and then it will immediately build it at the end of it, and which will return the mock response. So what this saves us, basically, we don't have to declare this everywhere. This is now void. We got rid of all of the with keyword. So this is just code, this is just header, this is just body, and this is basically code header body. And the build function also is no longer public, so that nobody else can actually build this thing. This is relatively concise code, and this will now describes our DSL completely. We have three things our DSL exposes. That's header, body, header, code, and body. And that's exactly the only three things that we can do inside this function. So this cleans up already quite a lot, but it still doesn't solve this problem down here. This is still a relatively complex object, and it's not a function. I'm passing in a function, so this is not exactly the code that is being used up there. So we have to fix this. The way we fix this is we basically accept an extension function to a body, to a buffer. In this case, I haven't created a special builder for that because the buffer class, this is like OKHTTP buffer, or actually OKIO buffer, which is a sub-library of OKHTTP, which is relatively already advanced, and it can do a lot of things for us. So I don't need to actually wrap that into a buffer. I just want to be able to do something inside that function. So this is now basically a complete code. I mean, they're not implemented, but yeah, if you implement all of these functions, then you basically get this DSL. So how do we go about making sure that this thing here is just accessible as a DSL, and I can't call it from anywhere else? There's one more trick that usually DSLs do. Question or okay. There's one more. Oh yeah, sorry. There's also an extension function. So this is the one that I was talking about. Like by default, the buffer also doesn't actually know how to read from test assets, but it knows how to read from an input stream. And all this function does is basically taking a string and then opens it as an input stream. So and you can do that relatively easy with the context. So this is the extension function that is kind of used in here. Which basically just reads this JSON into the buffer, and then this works. The last thing that you need to do in order to make sure that when you use like a nested function like this, if this was a normal function, like if I didn't have this annotation, inside the body here, I can also call header and I can call code, and that will compile and run. Because of how Lambda closures work, everything that is enclosed, which is the closure of this Lambda, is also accessible inside the Lambda, right? So if you pass in Lambdas somewhere, you might want to modify the object that is outside. But this is unwanted behavior when you build DSLs. You don't want to be inside the body here and actually change the response code. Usually you want to make sure that you do these things only in the places where they're defined. So this little annotation here basically tells the compiler that these three functions can only be called when the default receiver of the place where they're invoked is this. Like this is equal to mock response builder. And this is the case only within this Lambda here, because I'm expecting a Lambda with a function with receiver here, implementing it as a Lambda. So because it's an extension function, a function with receiver, the receiver type matches this type down here. That means that these three functions are accessible. In any other Lambda, which is not of that type, these three functions would not be accessible. So also, I can't create this builder myself and call these functions. That also is not going to work. I have to really use a DSL in order to call these three functions. That's the only way to actually use it. And that's basically the final piece that transforms a regular builder into a DSL. That's all the magic that Kotlin has in order to convert your builders to DSLs. So with that, do we have a final slide? Yeah, we do. Yeah. Thanks for coming. Do you have any questions on anything, DSLs or not?
Just wondering what the internal constructors are.
So the question was about the internal constructor syntax. And so we've looked already at how constructors work. And it's basically, sorry, just go to here. Usually you just have the class and then immediately followed by the parentheses, and then you have your arguments inside. However, if you want to, by default, that constructor here will have the same visibility of the class. If you want to have a different visibility for your primary constructor, then you have to use the constructor keyword, and then you can use stuff in front of it. So also, if you want to annotate the constructor, this is the way to go. So you declare first your type, and then any annotations on it, and then the keyword constructor, and then this. It basically is, if the visibility of your constructor and you have no annotations for the constructor specifically, then you can just basically omit this part. But this is like implied that it's always there. Any other questions?